Sathyabama Institute of Science and Technology.
Hi dynamic learners, wish you a very blessed day from Dr. A. Viji Amutha, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. In this video lecture, we are going to discuss a sorting technique, that is Radix sort. So the Radix sort, the main idea is to do digit by digit sorting, starting from the least significant digit to the most significant digit. So by repeatedly sorting the elements according to their significant digits, Radix sort achieves the final sorted order. So it is a non-comparative integer sorting algorithm which sorts the data by grouping the keys by the individual digits. So there are two classification of Radix sorts. So they are LSD Radix sort and MSD Radix sort, that is sorting according by least significant digit and by the most significant digit. So here is the algorithm for Radix sort, but before going to the algorithm, let us see an example and then we will come to the algorithm. The elements are given here, the input elements 402, 683, 725, 760, 105, 416, 528, 340, 375. So the Radix sort, it starts by sorting the least significant digit. So here let us see the first number, that is 402. Here the least significant digit is 2. So this number 402 is placed in the second location. Okay, that is the second row. So in the second row 402, the number 402 is placed. Now let's take the next number 683. Here the least significant digit is 3. So you put this number 683 in the third place. So in the third place 683 is inserted. So likewise we insert the numbers in the correct location according to their least significant digit. So we have placed the numbers according to their least significant digit in the correct positions. So finally we get the numbers as, we obtain the numbers as 760 and 340 are in the 0th position, and next comes the number 402, then 683, then 725, 105 and 375 are in the position 5, and 416 in location 6 and 528 in location 8. So we write the numbers. Okay, so this is the first phase. The first phase gets over and we write the numbers, sorted numbers like this. So in the second phase, we take the middle digit and we sort it. So here the first number is 760. So here we have to take the numbers we have got after sorting in the first phase. So first number is 760, so the middle digit is 6. So we place it in location 6. 760 is placed in the location 6. Then we have 340, the middle digit is 4. So we are placing in the location 4. 340 is placed in location 4. The next is 402, so it should be placed in location 0. So likewise we get the second phase. Okay, so we sort in the second phase. So after the second phase gets over, the sorted numbers are 402, 105, 416, 725, 528, 340, 760, 375 and 683. So now the first phase and the second phase are over. Now we have to sort it in the third phase. So in the third phase, we take the most significant digit. So the output from the second phase are 402, 105, 416 and so on. So these numbers are sorted again by the most significant digit. So let's take this number 402. So the most significant digit is 4. So it should be inserted in the fourth position. So you can see there 402 is inserted in the fourth place and 105. So here the most significant digit is 1. So it should be inserted in the first place. And 416, again we have the most significant digit as 4. So it should be inserted in the fourth place. So already we have 402 in the fourth place. Now we have one more number, that is 416. So After the third phase, we get the elements like this. The results are 105, 340, 375, 402, 416, 528, 683, 725 and 760. Now we see that the elements are sorted. All the elements are sorted. So here in the radix sort, the number of phases will be equivalent to the number of digits of the number. So here the input array contains the elements which have 3 digits. So here we go through 3 different phases. Okay, suppose if the input array consists of numbers with 4 digits, so we have to take the maximum digit. Okay, from the input array, you take the maximum digit number. If the number of digits is 4, then it has to go through 4 different phases. So you have to make the other numbers equivalent to 4 digits. Let me give you an example. So if one of the numbers is 3757, so it's a 4-digit number. So you have to make the other numbers equivalent to 4-digit. So how do you make it as 4-digit? Just insert a 0 in the most significant digit. So 402 will become 0402. 683 becomes 0683. So likewise. So you make the number of digits equivalent to the maximum digit number, and then you can do the radix sort. Now let us go to the previous algorithm. So the radix sort takes 2 parameters. One is the input array A and n is the total number of elements. So here m is the maximum number from the given input array. So the maximum number is m. So find the number of digits of the maximum number and let it be d. Make all the elements have d number of digits. So that is the first step. So this particular for loop, okay. So here we have actually 3 for loops. For I equal to 1, I less than or equal to d. So this for loop runs d number of times. And next we have the initialization phase here for r equal to 0 or less than or equal to 9 or plus plus count of r. So this is actually we initialize the count array. Okay, we initialize the count array. And then we have another for loop for j equal to 1, j less than or equal to n, j plus plus. So here this is the loop where we are inserting each and every number from the input array into the radix sort array. So here we insert the element according to their least significant position. So here let's see this line, p equal to extract of a of j comma I. So the value of I and j are 1. So it is extract of a of 1 1. So you are taking the first number. In the first number you are taking the first digit, that is the least significant digit. So in the example that if the number is 402, so you are taking the digit 2 and you are putting in the proper position. So now p becomes 2, and then in the next line b of p count of p equal to a of j. So here the value of p is 2. So we are inserting the number 402 in an array B. So in the array B we are inserting it at the second row 0th column. Okay, so 402 is inserted in the second row in the 0th position. So now after inserting the number in the correct position, you increment the count variable. So the next for loop. So we have the variable s equal to 1 and we have nested loops for t equal to 0, t less than or equal to 9, t plus plus. Again we have k equal to 0, k less than count of t, k plus plus. So this is the place where we are sorting. Finally we sort and we insert the elements from the buckets, that is elements from each and every row in the radix sort, and we are inserting it to the A array. So by the side it is the explanation is given. B of 0 0 is taken and it is inserted in the first place of A array. That is the element at the 0th row 0th column is taken and it should be placed in the first location in the array A. So likewise we take the elements from each and every array from B and we are writing it into one A array. So finally we get the sorted list. So what is the advantage of Radix sort? So it has a linear time complexity, so it is faster than other comparison based sorting algorithms like quicksort and merge sort. And it is a stable sorting algorithm. That is, the elements with the same key value maintain their order in the sorted output. And it is efficient for sorting large number of integers on strings. So the disadvantage of Radix sort is it is not as efficient for sorting floating point numbers or other types of data that cannot be easily mapped to a small number of digits. And it takes a significant amount of memory to hold the count of the number of times each digit value appears. So it is not efficient for small data set or data set with a small number of keys. So the application of Radix sort, where it is applied. So in a sequential random access machine, the records are keyed by multiple fields. So in that case, Radix sort can be applied. For example, if you want to sort on 3 keys, month, day and year, you can use Radix sort. First you can sort by year, then you can sort by day, and then you can sort by month. And then another application of Radix sort is it was used in card sorting machines with the 80 columns, and in each column a machine could punch a hole only in 12 places. The sorter was programmed to sort the cards depending upon which place the card had been punched. This was used by the operator to collect the cards which had the first row punched, followed by the second row, and so on. So now we come to the analysis part. So the time complexity of Radix sort is given by big O of d multiplied by n plus b. So here d is the number of digits and n is the number of elements, and b is the base of the number system used. So the base can be 2. If it is a binary number, the base will be 2. If it is a decimal number, the base will be 10, and so on. So the base is a constant. So we can ignore the constant and we get the time complexity as big O of d multiplied by n, d into n. Okay, so it is also a linear time complexity. So in all the cases, worst case, best case and average case, it has the same time complexity, that is d into n. It's a linear time complexity. So thank you learners for listening the video patiently. We'll see you again in the next video lecture. Thank you.